everyone, welcome to Learning at 11th Hour. In this video, I'll be telling you about three different latches. The first one is JK, the second is D, and the third is T. Here, JK stands for Jack Kilby. They are the ones who came up with this configuration so as to overcome the drawback of the SR latch. The problem with SR latch was that for all the inputs, it worked just fine, where we had for 0 0 input, the next state was the same as the previous state, so therefore no change. For 0 1, the next state was reset. For 1 0, it was set. But for 1 1, both qn and qn bar tried to arrive at the same binary state, which is not possible because they have to be complement of each other, and therefore this was called as an undefined or indeterminate state. Now, in order to overcome this issue, a feedback path was used, and it is seen that for this particular 1 1 input, both the outputs do not try to arrive at the same binary state. So, then what happens to it? So, let's look at the working of this JK latch. So, here, if we consider initially that Q is 0, so therefore Q bar is 1, and we are now going to look at the JK Qn plus 1 being the next state. So again, we can have four combinations 0 0, 0 1, 1 0, and 1 1. It is interesting to note that JK works very similar to SR, wherein J is similar to the S and R is similar to the K. The only extra added advantage is even 1 1 input is allowed over here. So therefore, it means that for 0 0, there won't be any change in the output. For input 0 1, the next state is going to get reset. For 1 0, the next state is going to be set no matter what the previous state is. And for 1 1, whatever was the previous state, that is Qn, the next state, Qn plus 1, will be the complement of it. So Qn is the previous state, Qn bar therefore will be the next state. So this becomes the characteristic table of JK latch. So here we have no change, reset, set, and this is called toggle. So whenever a 1 1 input arises at the JK latch, it's going to toggle. Now let's check that. Let's cross verify. So say because the previous input of this JK latch was 0 1, the output became 0 and 1. Because when JK's inputs are 0 1, the Qn plus 1, that is the next state, becomes 0. So here this is Qn plus 1 representing Qn plus 1. That instant will keep changing. The interpretation of the instant would keep changing. So when that input arrives, say it took up this form 0 and the complement is 1. Now when 1 1 occurs at the inputs, what happens? So here this 0 travels down here, this 1 travels over here, so 1 and 1, this would become 1, 0 and 1. When it is NOR, the output will become 0. And this 0 travels here, this 0 travels here, 0 and 1 for this AND gate, the output would become 0. So the input to this NOR gate is 0 0, which means the output will become 1. So it was 0, it has become 1, right? Qn plus 1 has become 1 when it was 0 as Qn. So this means that the output gets toggled. So we can check this. We can't confirm it because even for this kind of input, 1 0, the output sets, right? So here also it appears as if the output has set. But if you check, if Qn was 1, it will toggle to 0, applying the same concept. So if you go through the same process, the same flow, you will see that if it was 1, it would toggle to 0. So therefore, finally, we can conclude that this is the characteristic table of JK latch, where For the input 0 0, there is no change. 0 1 is reset, 1 0 is set, and 1 1 is toggle. Now let's go on to the D latch. So this is the configuration of the D latch, where if you see, the D here stands for delay. So this means that if my input becomes 1 right now, it will get reflected at the output, and after a little amount of delay. So that is the concept of the D latch here, right? So here, whenever the enable is 1, only then this AND gate, the two AND gates, will be enabled. Because if this enable is 0, then one of the inputs to this AND gate would be 0, which means if one of the inputs to the AND gate is 0, the output of the AND gate will always be 0, no matter what the other input is. So to enable these AND gates, the enable pin has to be 1. Only then the other input would get rendered forward. So this is going to be 1. Only then these other inputs would be considered. Now, if you observe, this is the D input, and it is fed to one of the AND gates directly and to the other one in the complemented form. So this is D bar, right? Now, looking at this characteristic table of the D latch, when the enable is 0 and D is also 0. So what we get here is, when enable is 0, no matter what the other input is, this is going to be 0. Similarly, here we are going to get a 0. So the output is going to remain latched, or it will be held or locked, right? Same is the case for D being 1, because the enable is 0, right? So no matter what D is, the output is going to remain latched. But when enable is 1, so when this E becomes 1, what happens? So when E is 1, we see that the D and D bar go in. So here what we get is, we'll get D bar over here, and here we are going to get D. So depending on what the previous output was, right? Suppose if this was 0, then the 0 will be fed over here, and 0 NOR with D. So 0 OR with D the whole bar. So we'll get D bar. And here, this is going to be 1, right? So when 1 is NORed with D bar. So 1 ORed with D bar the whole bar. So 1 plus anything is going to be 1, and the toggle of that is going to be 0. So we see that when D is 0, Q is also going to become 0. Similarly, when D is 1, Q will become 1. Therefore, Q bar will be the complement of Q. So therefore, 1 and 0 respectively. So that's how this characteristic table of the D latch is formed. So this completely depends upon the enable input. If enable is 0, then the Q remains latched. Let's move on to the last flip-flop, that is the T flip-flop. Here, this is the configuration of the T latch, where T stands for toggle. So the concept here is, when T is equal to 0, the next state will be the same as the previous state. But when T is equal to 1, the next state will get toggled. So when the toggle switch is high, or the toggle switch is on, it will indicate the next state to get the toggled version of the previous state. So let's see how this works. Let's consider that Q was 0. So ideally, after, if the T input is 1, then Q should become 1. It should toggle to 1. So let's see if that happens. So this 0 is going to travel down here, and if the Q is 0, Q bar will be 1. So this 1 will be fed back as 1 here. The input to this AND gate is 1 1, because T is also 1. So output of this AND gate is 1. 1 and 0. The input to the NOR gate is 1 0, and the output would therefore be 0. Now this 0 travels up, and the 0 at Q would be fed back here, and the T is 1. So the output of this AND gate is 0, 1, here it's 0. The input to this NOR gate is 0, 0. Therefore, the output is going to be 1. So we see that 0 has toggled to 1. We can see that if the Q was 1, it would toggle to 0, provided the T input is high. If the T input is 0, then Q will remain at 0 if it was already 0, or it would remain at 1 if it was already 1. So, having said that, I could write the characteristic table in this manner. So, for T is 0, next state is Qn. For T is 1, the next state is Qn bar. So, this is one way of representing the characteristic table of the T latch, the toggle latch. So, that's all with today's video. I hope the working of JK, D, and the T latches are clear to you all. And also the characteristic tables of all the three latches was understood by you all. If you have any queries, please don't hesitate to post it in the comments. And thanks for watching the video.